For the beam shown, we are tasked to find the reaction at the left end of the bar AB, the reaction at E, and the reaction at the right end of the bar CED. To solve this, we consider the free body diagrams of each individual beam. So first, let's draw the free body diagram of beam AB. So for beam AB, we have a pin support at A, therefore it induces a vertical and horizontal reaction, let's call it AX and AY. And we have a 2 kN force acting at 1 meters from the left support and 0.6 meters from the left support. And we have a reaction at B due to the roller, therefore it only induces a vertical reaction, let's call it BY. To solve for the three unknown forces, we'll make use of equations of equilibrium. First, let's take summation force Fx equal to 0. So we have Ax, since it is the only force acting on this member, and no external forces acting horizontally on this beam, therefore Ax is equal to 0. Taking summation force y equal to 0, we have Ay plus By minus 2 kN force equal to 0. Since we have two unknowns, we make use of the other equation, that is summation of moment at points. We can choose point A, summation of moment point A equal to 0, taking counterclockwise to be positive. So we have a negative 2 kN force because it induces a clockwise moment, therefore it's negative, multiplied by the moment arm distance of 1 meter, then plus the force By, since it induces a counterclockwise moment, it is positive, multiplied by the moment arm distance of 1.6 equal to 0. And we can solve for By, that is equal to, we have negative 2 times 1 plus By times 1.6 equal to 0. Shift solve, we get By is equal to 1.25 kilonewton. Now that we have By, we can plug in this value into our equation. We can solve for Ay, that is Ay plus 1.25 minus 2 equal to 0. So Ay is equal to 2 minus 1.25, which is equal to 0.75 kilonewton. So let's draw these values into our figure. So if Ax equal to 0 and Ay equal to 0.75, and the reaction at the roller at B, that is equal to 1.25 kilonewton. Now we can proceed analyzing the free body diagram of beam CED. So it has a roller, the left support, so it will induce a downward force of 1.25 kilonewton, which we solved earlier, and a roller at E, let's call this EY, a pin support at D, therefore it induces a vertical and horizontal reaction, and a 1 kilonewton force acting 0.6 meters from the right support and 1.2 meters from the left support. Now to solve these three unknown reactions, we can make use of the equations of equilibrium. Taking summation force vertical, since only dx is acting on the beam, therefore its value is equal to 0, because there are no external forces acting horizontally on this beam except dx. And to solve for Ey and dy, we can take summation force vertical equal to 0. So we have Ey going upwards plus dy minus the 1 kilonewton force going downward minus the 125 kilonewton force equal to 0. And then take summation moments at point D equal to 0, considering counterclockwise to be positive. We have a 1.25 kilonewton that induces a counterclockwise rotation, so it's positive, multiplied by the moment arm distance of 1.8 meters, minus the clockwise moment of Ey times, it has a distance of, this is 0.6 meters, so plus 0.6 meters, therefore this distance here is 1.2 meters. And we have a counterclockwise moment of 1 kilonewton, so it's positive, multiplied by the moment arm distance of 0.6 meters, which is equal to 0. And we can now solve for the value of E1. There is 1.25 times 1.8 minus Ey times 1.2 plus 1 times 0.6 equal to 0. Shift solve, we get EY equals to 2.375, or approximately 2 equal to 2.38 kilonewtons. Now that we have EY, we can now solve for DY using this equation. So that is EY 2.38 plus DY, represented as x minus 1 minus 1.25 equal to 0. Shift solve, we get dy equal to negative 0.13. Therefore, dy is acting in the opposite direction since we have get a negative sign in our solution. So to solve this problem, first, the reaction at the left end of the beam, that is equal to 0.75 kilonewtons, and the reaction at E at the roller, that is equal to 2.38, or approximately equal to 2.40. And the reaction at the right end of the bar, CED, that is equal to negative 0.13, that is approximately equal to 0.125.